Hello everyone, welcome to the session on serverless architecture. In this session today, we'll be talking about the fundamentals of serverless style development and doing some demos and giving you an idea of what serverless architecture really is and how it compares to microservices and monolithic style architectures. My name is Pratik Patel. I'm a lead developer advocate at IBM, Java champion, and the other things that are on this screen. You can follow me on Twitter at @prpatel to follow up, or if you're interested in continuing and learning more about this, you can also reach out to me on Twitter, and I have some full day, half day workshops that I'd be happy to walk you through so you can get your hands dirty and really dig into what it is that serverless development is. So we'll be doing some of our demos today using Apache OpenWhisk, which is an open source serverless platform. We'll also be talking about OpenShift and Knative. And the Java examples we'll be doing, we'll be using the Eclipse OpenJ9 open source and free Java virtual machine. So you should check those things out when you get a chance. All right, so our rough agenda for today is what is serverless? We'll dive into architecture as well, and we'll talk about the ecosystem and other things like that. Okay, so first of all, serverless. Number one, serverless is a very bad name. Now, the premise behind serverless is that you don't have to worry about the infrastructure and the individual servers and all those other things that you have traditionally had to think about when you're deploying and building an application. So there's someone in the cloud space named Kelsey Hightower. You may follow him on Twitter. He tweeted out a couple of years ago, we asked 10 different people to define serverless. We got 10,000 different answers. And of course, this is social media, so the responses were hilarious. One of them was, we asked developers to write one line of code. Instead, we got 10,000 containers. That's a little bit of a jab at this whole containerization kind of world that we live in now. And since this is Twitter, someone posted, serverless is GeoCities for the enterprise. Now, I'm not sure if I would go that far. If you don't remember what GeoCities was, you can have a look at this little GeoCities generator that I use to basically simulate a GeoCities website, if you remember GeoCities from back in the day. But let's talk more about serverless and what it means. Yes, there are still servers. So in serverless technology, in serverless development, there's still servers somewhere, right? So we think about serverless technology because of two key points, which are building for and deploying a serverless style application is cheaper and should be easier. And we'll also talk about how it simplifies the overall development process. Okay, so there are a couple of different things that we can say when we're discussing serverless technology, or some aliases. So serverless itself is an overall umbrella of different technologies that include the cost model, the deployment and management, and other things like that. But what we're going to be specifically focusing on in this session is the cloud functions aspect of it. So sometimes I'll refer to the units of code that we're building and deploying as either cloud functions or functions as a service. Okay, so I'll be using these two terms interchangeably. And again, serverless is more like an umbrella term that encompasses everything that comes under the different types of serverless technologies, whether it's the pricing model, serverless databases, on-demand types of things, etc. We'll talk more about those in a few minutes. So I'd like to start off with a good definition. Serverless is run code without provisioning or managing servers. That's the basic premise of building in a serverless style architecture. One way that I like to think about it also is that it's all the dev and none of the DevOps. Okay, I know DevOps is a big thing, and yes, serverless may require some DevOps, but the idea is that we want to reduce the amount of work that we do to build an application and to deploy and manage an application in production. Serverless also takes care of these things: scalability and availability, so that you don't have to go in and configure everything and adjust things over time, etc. The serverless platform should be able to take care of these things for you. It detects more load, it starts up more instances, it scales down when it needs to, etc. Now, One thing that I like to talk about up front with serverless technology is the way that it's priced. So when you typically go and rent a server in the cloud, how do you pay for it? You pay for it for the exact amount of time that you have it up and running. So if you go and rent a server on a daily, weekly, or monthly basis, you pay for that server whether or not you're using it for the entire period of time that you're renting it. The way serverless tech works, however, is that you only pay for the invocation. So here's a simple formula on how serverless technology and cloud functions specifically are priced. So you take the amount of CPU time that is used by an invocation of your serverless cloud function times the amount of memory times some really small fraction of a cent. Actually, we can add some more zeros to this 2.002 there, and that's the cost that you pay for exactly the execution of that one invocation of that cloud function. So it's essentially the pinnacle of on-demand computing, and that's how you pay for it. Okay, so the pricing model is super flexible, but it's also a new architectural model. We have to think differently when we build for a serverless style of architecture. All right, and that's what we want to talk about here. So I like to use an analogy here in terms of where we've been and how we're going in terms of software development. So if you remember back in the days of the mid 90s or late 90s, we did microcomputer style of development. And then we quickly transitioned over to software as a service into the late 90s and early 2000s. But what is microcomputer development? That would be using something like Power Builder or Delphi or something, and then you take your application, put it onto a floppy drive or a CD, and go and install it on everyone's computer that needs the software. So obviously we don't do that anymore. And the leap that we made from the microcomputer to the software as a service style of development was that we were able to deliver our applications through the web without the user having to install anything. Of course, we still use binaries and executables to deliver software, but we made this massive leap where the user could just go to a website, click refresh, and they would have a new version of our application with no installation and very little hassle to get the latest version of the app, right? So we're in this transition right now, I feel. We're going from infrastructure as a service and platform as a service to serverless style computing. We still spend a lot of time thinking how big our server should be, what different load balancing and other things that we need, and then going and configuring all those things. With serverless style computing, we don't have to worry about all those things. We take our code, we provide it to the serverless platform, and it worries about configuring the instances, scaling them up, scaling them down as demand goes down, etc., etc. So we're making a little bit of a leap here, right? Maybe a giant leap depending on how far we're able to take the serverless style development and produce software in this architectural style. So if we think about where we've been or where we are today, right, we have infrastructure at the bottom of this pyramid, and then we have platforms on top of it, whether it's Linux or Red Hat or Windows or whatever you're running on. And then we typically build with containers, and then we deploy those containers and maybe orchestrate them using Kubernetes, and then that's how we build a full application. Now, when we think of serverless and functions as a service, we have another abstraction layer there underneath our application where we build things as functions as a service or cloud functions. And underneath those things, we have containers, platform, infrastructure, just like we always do. But with serverless technology, that infrastructure is somebody else's job. We don't have to worry about it, right? So if we look at this evolution from a different point of view, you can go all the way back to the early 2000s where we were literally installing operating systems, and then we would install an application onto that operating system on a Sun server or some kind of Linux machine or whatever. And we realized we weren't making good utilization out of these servers that we had. So we used virtualization software and put virtual machines on them, and we were able to run multiple applications on the same server. And then, of course, in this world of Docker and containers, we went even smaller, where the Docker container is very small and not necessarily a full operating system like a virtual machine. And then the next step in this evolution is cloud functions, where you don't even think of those things underneath so much. We're moving and abstracting away the entire kind of operating system or container that it's running in. Okay, so there are some limitations. We'll talk more about limitations as we get through this presentation, but some kind of basic limitations is the amount of execution time your cloud function is running is limited by the cloud function provider platform. It's so currently on Apache OpenWhisk and IBM Cloud Functions, I believe the default is 10 minutes. That can be increased, but we don't generally want to have our cloud function running for that amount of time. And when I say running, I mean actually executing our code, not if it's alive and ready for a request, but the amount of time that it takes once it gets a request, does some stuff, and returns a response, right? That's the execution time, right? We talked about it in the formula in a slide previously where we were discussing how much it costs. The other thing is a cloud function platform typically also has rate limits. So if your cloud function is getting utilized a lot, you want to be sure that you know what's going on. So there are rate limits so that your cloud function may only get executed 1,000 times a minute or 10,000 times or 100,000 times, whatever. Those are configurable, and it's like a safety net. So in case you have some kind of script that does load testing and you point it at production and all of a sudden you have this massive bill because you hit this cloud function like 1,000,000 times in an hour, et cetera, et cetera. Those rate limits are safety nets so that you know that you're not going to go and hit that thing more than you expect at any given point in time. But when we think about this from an architectural point of view, Cloud Functions allows us to focus on building our application. Things like Docker and what operating system we're running and the load balance we're using, all those things, that's abstracted away and that is managed by the Cloud Function platform. Right? The idea is that we don't have to focus on those things, so we can focus on writing our code and building applications for our customers. That's the basic idea. Right? And then as we build these things out, we don't build everything from scratch. We'll use existing Cloud Functions that we've built and Cloud Functions that are off the shelf, maybe from other teams in our companies or even third parties. Right? We'll talk about those in just a few minutes. And of course, we have to write our own business logic, so we will write our own Cloud Functions or functions as a service as we go and build out a full application. In terms of architecture, Cloud Functions generally have a basis around an event-driven style model, but the events can be anything. An HTTP invocation, something coming in off a message queue, a trigger that is fired when something is inserted into a database or a schedule-based trigger, right? So, but those things are modeled as events, and that's the basic premise here, is that we are writing in kind of a more of an event-driven style than we may be in a traditional application. So what are some Cloud Function events, right? Message queue, something coming in off a queue, it goes in and invokes a function. HTTP call goes in and invokes a function. Database monitor, maybe an inbound email goes in and executes a function, right? So we take the data that is provided in the event, we pass it to the Cloud Function does its processing, and then returns a result, or maybe invokes another Cloud Function. Now, if we think about this for a second, some of the things that I've talked about are not necessarily revolutionary, they're evolutionary, right? We've been building stuff with event-driven style programming for a while, whether it's something like JMS or something more recent like Apache Kafka streaming. So to me, a lot of what we're building when we're using this Cloud Functions serverless architecture style is some of the best practices or some of the lessons learned distilled into something that is easier for us to go and build applications with. So I think of this more as an evolution rather than a revolution. And we may have already been doing this. At a company that I was at previously, we were building an application where we needed to do image OCR and then natural language translation. So we used those two things off the shelf, an image OCR API, a translation API, and then we wrote our own cloud function to add some additional business logic and call those two things. And it was very easy and very quick to build out this feature in our application because we're able to pull things off the shelf and then write a little bit of our code. And again, we don't have to set up a whole server and load balancers and stuff. We take our cloud function, we give it to a provider, a cloud function platform, and it runs it for us, and we don't have to worry about scaling up and scaling down and things like that. And so if we think of other things that we could model as APIs or cloud functions, right? Use something like Twilio for SMS, Stripe for payments, image resizing, sending and formatting an email, using something like MailChimp, doing authentication with IBM ID, App ID, or something like Okta, etc. There's loads and loads of these things that we can bring together so that we don't have to build everything from scratch, and we can get to building specifically what our user wants much faster. And so I like to think of this also in terms of another architectural shift. Say that we wanted to do image OCR 5 or 10 years ago. What would we do? We would reach for a library that does OCR, we would incorporate it into our application, and then our application would get larger, but we would have that additional functionality, right? So we would import the library, we would say new image OCR, blah, 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 and then we'd pass it in an image and it would do its thing, and we would go invoke the specific Java method or class or JavaScript function or Python function or whatever programming language we were using. But the shift that we're making here is we think that we're going to now create some kind of event with some parameters and invoke a function as a service, a cloud function basically. So instead of including a library in our project, we say, okay, I'm going to create a new cloud function that I'm going to fire with this event, with these parameters, and it will go run. So a little bit of shift in thinking as a software developer for how we're going to build out these things. Now let's do a quick comparison between a standard Java monolith application with some serverless principles. Okay, so when we think of a serverless cloud function, it should be small and a unit of work, and it should be single purpose. Now let's compare that to a standard monolithic type of application. And the short answer is no. Monoliths are not small, and they're definitely not single purpose. So that's one thing that we have to think about when we're shifting the way that we think about moving from a monolith style of software development to microservices, and then to top of the pyramid, serverless cloud functions. Okay. Now, serverless cloud functions should also be short running, and as much as possible should be stateless because of the, again, it's a new architectural model that we're building for. When we think of a monolith, is it short running and is it stateless? Nope, absolutely not. That's okay when you're building for a monolith style architecture, right? A monolith style architecture app, you start up and it just runs for days or weeks on end. And then you do some kind of staggered rollout when you need to update the application. And of course you use session objects and states and things like that. But again, we're talking about the architectural principles when we're building cloud functions in a serverless style architecture. So we have to think differently. Then there are solutions for how to work in this style of architecture. All right, so in a monolith style application, we also write code in a synchronous and asynchronous style. Do we do that in cloud functions? Short answer is yes. We have the ability to invoke cloud functions in a synchronous style as well as an asynchronous style. And because it's event driven, it's async in nature, but we can simulate the synchronous way of building things or executing things if we need to. All right, so let's talk a bit about FAAS implementations quickly, and let's get to some demos. Now, one thing to note is that you can write your cloud functions with a whole bunch of different things. We'll talk about that in just a second, but you can invoke them from anywhere, right? So if you write your cloud function in Java, you can invoke them from JavaScript in a web browser or from another Java application or from a Python application, or you can write a Python cloud function and invoke it from a web browser in JavaScript, et cetera, right? So the invocation can be done in a number of different ways or a number of different programming languages. So the demos we're going to be doing are going to be using the Apache OpenWhisk open source cloud functions platform. And that is what IBM Cloud Functions is built upon. Okay, so we're going to do the demos in that. And then of course, right now, Kubernetes and OpenShift is big. There is the ability to run a Cloud Functions style of environment using OpenShift and Knative. If you do a Google search, you'll find some documentation and some software that allows you to take an OpenShift installation and have a serverless style execution environment on it, which is great. We love choices as developers and flexibility to do different runtimes. Now, let's do a demonstration using Apache OpenWhisk. All right, so just want to show some code quickly here where we have a simple Cloud Function that takes in JSON and returns JSON. That's the premise of Apache OpenWhisk. Whenever you write a Cloud Function, the Cloud Function will consume JSON and will return JSON after it's done its business logic and processing. So in Apache OpenWhisk, IBM Cloud Functions, all OpenWhisk actions accept and return JSON objects. Okay, so the way that we deploy something like this is we would do IBM Cloud Function, create the function name, give it the name of the jar file, and then main, and then we can go and invoke it like it's shown on this screen. But let's drop down and actually do a live demo in just a second, right? So when you're writing in Apache OpenWhisk and IBM Cloud Functions, you can write your Cloud Functions in Go, in Java, JavaScript, Python, PHP, Swift, and interestingly enough, you can actually use a Docker container as the basis for your Cloud Function, which allows you to use native binaries. We'll talk a bit more about this also. Okay, so let's go over to our command line, and we have some Cloud Functions already set up here. So what I'm going to do is I'm going to execute a Cloud Function which I called QCLI test1. Not a great name, but whatever. I'm going to go run this, and we'll go have a look at the code in just a second. So this is actually going to go and invoke this on a Apache OpenWhisk environment. IBM Cloud Functions is based on Apache OpenWhisk, and you can see that this returned with a greeting of hello Pratik. And since this is the Digital Developer Conference, I'm going to just change the name and go run this again, and you'll see it says greeting, hello DDC. Okay, now let's go and look at the code for this real quick and see how this actually works. Okay, so we have here we have a very simple example that we're just going to go through. In this case, we have a couple of different endpoints using the fabulous Quarkus framework, and we're able to inject some different things. We have our hello here, for example, and that returns a very specific message, as you can see here. So this is one way we could do it. We could use a library like Quarkus, which compiles down to a very, very small executable, and or jar file, which we can then go and run very quickly, because Quarkus is meant to be fast starting because of pre-compilation and other things that it does at build time rather than at startup time. If we go look at a couple of different ways to do it, we could also use this specific method where we're using the Quarkus CLI mode to go and build out an application. You can see we're able to inject a service here if we need to, but as you can see here, we say JSON node, our root node, and this is using the Jackson XML library. We say go and get the name, and then go and put the greeting as a response when we go and execute this specific Cloud Function. If we go look at how this works, you can see that we have some code here inside of our service object, which takes and just constructs a simple string. But again, the idea here is that when we're building with Apache OpenWhisk and IBM Cloud Functions, we do JSON in and JSON out. We're showing this demo code using Java, and in this case, we're using the Quarkus library, but we could also just write it using plain Java if we're writing something very simple. If we wanted to just start off like something really, really simplified and easy for application, but it's nice to have a framework because it allows you to go and just kind of build things in an easy way, right? So you can go and look at the kind of very bare bones Java application using no framework, essentially just a JSON processing library. But you can see that we can't do dependency injection and kind of working with JSON at a low level here. It's nice to use a super lightweight framework like Quarkus to be able to do something like that. So if you're interested in this, again, please reach out to me on Twitter, and I can show you some different styles of building serverless applications using Java, both with and without frameworks like Quarkus. Okay. All right. So we went and executed our cloud function using just the command line, as you saw just a second ago. All right. So let's just go run that again. You can see we have this output coming back to us. We can also say, you know what, I want to invoke this from the web. So I can say IBM Cloud, or if I were running Apache OpenWhisk locally, and that's the great thing about open source, is that you can actually run that open source software on your own laptop. So I have an instance of Apache OpenWhisk, a full serverless cloud platform, running on my laptop when I'm doing development or debugging, or if I'm not connected to the internet. You know, I can go and just test all that stuff locally, which is great. But let's go and look at this running in the cloud. And so I'm going to grab this URL right here. Let's switch over to our web browser. And you can see I already have this up here. That's the URL I just got from the command line by doing -- URL. Right? So there's -- URL. So let's go back here. And if I go invoke this, you'll see that it says hello Pratik. And now if I go and let's just replace this like we did on the command line with Digital Developer Conference. And if I go run that, you'll see I get that result back, right? So, and the way that we would go and deploy this is we would do IBM Cloud. Well, first what we would do is for our Java project, we would do Maven package and allow Maven to go and package and create a jar file from our application. And it looks like I'm not in the right directory, so it helps if you're in the right directory. Let's do Maven package. That will go and package our application for us. And then once this is all built and running, I'm just going to kill this for now. I would do IBM Cloud function action, and I would either do create or update, right? I already have this cloud function. Well, we can create a new one, right? So we can do IBM function action create, and we'll call it DDC test one, something, I don't know. And then we would pass it the location of our jar file. So let's go find our jar file, right? There's runner. And in this case, I have a specialized Docker container that I'm using where I take the jar file and put it into this Docker container, which is meant for this Quarkus CLI super lightweight application. And the Docker container already has all the Quarkus libraries and other things like that inside of it. If I weren't using Quarkus and I was just building a simple file or a simple thing using just like plain Java like this, what I would do is I would just basically give it the jar file, and I would have to do main com.example.function app, and that would go and create that thing for. So that would go and create that thing for us. And once that thing has been created, we're able to go and execute it as we saw previously from the command line by running the invoke command. In this case, this -- result says that don't wait for it to execute and send me a message later. Let me know what the result is immediately. So this is like doing a synchronous execution. So if we were to go and take this result part out, you could see that we get an activation ID now. And then we can go and get the activation ID by issuing another command like so. That would go and it helps if you go and say get the activation, IBM Cloud function activation get. So let's go and so get it, and now we can see we get a more detailed example or more detailed result. But you can see that here it says success, and then here's the actual result. So what we did, let me rewind here real quick. What I did is when I don't include -- result here, that means this means with -- result, do a synchronous execution, i.e. wait for it to execute and then give me the results back. If I don't have that in there, it will just go and execute it. and then I can use this activation ID to go and actually get the result of that execution or activation. And you can see this comes up. So this is a way of doing asynchronous execution of our Cloud Function. If you remember, we talked about both synchronous and asynchronous execution of our Cloud Function. Okay. All right. So, of course, if we wanted to go and create or update our Cloud Function, instead of doing a create, we would do an update and pass it a new jar file or a new code bundle if we're doing it in Python or JavaScript or whatever. So it would not totally destroy the settings that we had for our existing Cloud Function. It would just replace the code, right? And one more thing as part of this demo, let's go and actually call this from a web browser, right? So yeah, it's great to call this from the command line and see it work and all that kind of stuff, but how do we actually go and call this from a web browser or an HTTP endpoint? Right, so what we can do is we can say, hey, give me the URL for this. So I'm going to grab this URL and we're going to open a web browser now. I'm going to put this in, and then I'm going to say I want this as executed as JSON, and you can see I'm doing question mark name equals something. That was the parameter we used previously to pass a parameter to the Cloud Function. Let's go and invoke it, and you can see this says hello DDC. So if I go to raw data, you can see that we have this specific parameter there, and we're able to invoke the function. If I go and change the name to Pratik and go and invoke it, you can see that that's what we get now. Okay, so with this, let's get back to our slides and talk about some final things and get an idea of where we're going. All right, so when we think about serverless technology and how we build Cloud Functions, we don't necessarily want to continue to think about setting up, configuring servers, configuring load balancers, and all those kinds of things. We want to focus on writing the code and let the app run in a Cloud Function platform, and let the Cloud Function platform manage the scaling up and scaling down of our application. So one thing to note is that earlier I said we want our Cloud Functions to be small, right? And that's for two reasons. The first reason is that we want to be able to put together independent Cloud Functions to create a sequence of Cloud Functions to do more complex and elaborate things. So our Cloud Function should only do one thing, like store something to a database or go and validate this data. So that way then we can take that validation function and then merge it with the save to database function, and now we have a new function, or what we call a sequence in Apache OpenWhisk, that allows us to have a single endpoint that does both those things. So we compose things not necessarily just at the code level, but we compose things at the Cloud Function level also, which is super important. The other thing is the Cloud Function provider will scale up our application as more concurrent requests comes in. More instances of our Cloud Function will be available to handle more concurrent load. But we also have the possibility that the Cloud Function provider will scale down our application and even scale it to 0. So if we keep our Cloud Function small, they will start up much faster. So we have to be cognizant of startup time. We don't have to focus too much on it, but we do have to be aware of it, that our Cloud Function should start quickly so that the user doesn't have to wait for some operation to complete. Right? So another thing about Cloud Functions is we want to keep them simple, and we want to try to keep them stateless. Now, there are ways of doing state underneath the hood, but we want to offload that state management either to a layer above or a layer below. Right? That's something that I talk about in the workshops that I do. So if you're interested in getting your hands dirty and seeing what that actually means and what that looks like, whether you program in Java or JavaScript or whatever, we can do hands-on workshops so you can actually write some Cloud Functions and see how composition, sequencing, stateless style of architecture all comes together. All right, so let's talk about a few final things here. I talked about the execution cost and how Cloud Functions are charged by the amount of time it's actually executed. Not how is it alive on the cloud and just running, but is it actually being executed? That's how we pay for it. But oftentimes as a developer, the execution cost is the least important thing for me. If I can have somebody not focused, someone on my team not focused on doing a lot of DevOps stuff or managing the configuration and keeping an eye on doing maintenance all the time and applying security patches to the underlying infrastructure, the platform or the operating system that I'm running on, I could use that person to focus on what my customer wants in terms of features or any other things that we do for software development. So by offloading those DevOpsy types tasks to the platform and letting the automation do all those things, I can actually get more work done and build more applications. So yes, I care about the execution cost, and it's great having lower execution cost or lower cost overall, right? And you can get overall a lower overall cost. A lot of serverless applications, actually the vast majority of serverless applications actually have much more lower cost than the same application built using a monolith or other styles of development where you're just renting the server for the whole time, whether or not you're utilizing it 100%. Because in a serverless style architecture, you're only paying for when your code is actually executing. You can actually save a lot of money and possibly even run your application for a fraction of the cost and not have to worry about scaling it up and scaling it down, because the Cloud Function platform will do that for you. Okay. The other thing is, because I'm writing in smaller bits and I'm doing composition at a slightly higher level, I can get to market faster. That means I can build applications faster, especially since almost all my focus and my dev team's focus is on building the application and writing code and seeing what the user wants and all those different things that we do in software development. Since we don't have to dedicate as much time on the infrastructure, we can focus on our application and our customers' business needs and get to market faster, which I think is great, right? And with those two things that we just talked about, we can reduce the overall cost of developing a new feature or an application, right? So if we have more people focused on what the customer wants, if we're spending less time doing DevOps, we can focus on our application and reduce the overall cost of development. So thank you for listening. Please follow on Twitter. If you would like to do a workshop, we have free workshops that we would love to do for you. So please reach out. Let me know. We have 2-hour, 4-hour, and full-day workshops and multi-day workshops around serverless technology, building cloud functions, and learning all these things. Thank you for listening, and please ask me some questions. Love to engage in more discussion